Let's figure out how many bonds nitrogen can form using the periodic table. Now, the periodic table is arranged in groups. As you can see, I have highlighted some of the group numbers here in blue. So the main group elements, that's groups 1, 2, 13, and so on. If you take the main group elements group number, the last digit of the group number, that actually will tell you how many valence electrons the atoms in those columns have. So let's take group 1, for example. All the atoms in this column have 1 valence electron. Group 2, 2. Group 13, remember you take the last digit of that group number. So that's 3, 4, 5, 6, 7, and 8. Now we can see here that nitrogen is in group 15, which means that it has 5 valence electrons. Now, just as a reminder, a lot of the atoms want to achieve the octet rule, which is like the noble gases, which are very stable, and all of the atoms are very happy with the octet rule. So in order to go from 5 to 8 valence electrons, nitrogen will need 3 more. Let's draw nitrogen's electron configuration to help you see that right away. So remember 5. So 1, 2, 3, 4, 5. So with this electron configuration, you can see that nitrogen has 5 dots around it. 2 of them are paired, and 3 are single electrons, still unpaired. Each of these unpaired electrons can form a bond by sharing with another atom's electrons. So let's show that sharing right now. So you could have another electron, another, and another. So that is why nitrogen forms 3 covalent bonds, 1 for each of the unpaired electrons. Let's show some examples depicting this. So here you can see with ammonia that nitrogen has 3 single bonds with a hydrogen. So there's 1 bond, 2 bond, and 3 bond. So you can see where the 3 bonds come from. Again, here in this nitrogen gas, you can see that 2 nitrogen atoms share 3 pairs of electrons, 1, 2, 3. So both of these nitrogens have 3 bonds. And you can see here that they can be single bonds or triple bonds. It just needs to add up to 3.